This problem says, how high a hill can a car coast up? Engines disengage if work done by friction is negligible and if its initial speed is 110 kilometers per hour. Okay. Alright, so part A, let's draw a hill, and here is the car initially, and here's the final position, and if there's no friction present, energy is conserved, and kinetic energy initial plus gravitational potential energy initial is equal to final kinetic energy plus gravitational potential energy final. So this would be Y final, and Y initial is 0. So initial gravitational potential energy is 0. 1/2 mv initial square is equal to 1/2 mv final square. When it comes to the top, it's at rest, so K final is 0. mgy final. Okay. So the mass cancels, meaning every car going at that speed will reach that height. So Y final is equal to V initial square divided by 2g. So this is how high the car will rise if it's going at that speed. Alright, now let's convert the speed into meters per second. So V initial is 110 kilometers per hour. 110 into 1,000 meters divided by 3,600 seconds. So the initial speed works out to 30.6 meters per second. Alright, so Y final is 30.6 divided by 2 times 9.8 meters per second squared. 47.6 meters. Okay, so that's how high the car would rise. Okay, so in part B, let's add a page below. In part B, so they say, well, it should have risen if there's no friction, the car should rise up 47.6 meters. But it rose up, in actuality, it only rose up 22 meters. And so we want to calculate how much thermal energy was generated by friction. So we have to calculate how much work friction did. And so let's, so it only rose up 22 meters. Okay, so it should have gone up that far, but this is how far it went. Alright, so that's 22 meters. Okay, so now the deal is work done by gravity plus work done by friction is equal to change in kinetic energy. Okay, this is 0. Work done by gravity is UG final minus UG initial plus work done by friction is equal to minus KE. Alright, so work done by friction is And final kinetic energy, final potential energy minus initial potential energy minus initial kinetic energy. And initial potential energy is 0, so this guy is 0. Okay. So mgy final minus 1/2 mv initial square. Okay, so the work done by friction is 750 kgs times 9.8 meters per second square. And remember, it only rose 22 meters minus 1/2 750 kgs. And initial speed was 30.6 meters per second. And of course this should work out to be negative, so let's do this. 750 into 9.8 into 22, okay, minus 0.5 into 750 into 30.6 squared. And so this works out to 1.89 into 10 to the power 5 joules. So that's how much work friction did. And when friction does, what friction does is it removes this much mechanical energy and converts it into thermal energy. So the increase in thermal energy is 1.89 into 10 to the power 5 joules. Okay. Now part C, what is the average force of friction if the hill has a slope of 2.5 degrees above the horizontal? Okay, so let's add a page. Now we know how much work was done by friction, so this is 22 meters, this is 2.5 degrees, and there's the friction force, and there's the distance. Okay, so let's calculate the okay, d, the slope is, okay, sine 2.5 degrees is equal to 22 meters divided by d. So d is 22 meters divided by sine 2.5, which is 504.4 meters, okay, half a kilometer. So all right, so the work done by friction is minus F times D, and that's equal to minus 1.89 into 10 to the power 5 joules. So friction force is 1.89 into 10 to the power 5 joules divided by D, which is 1.89 into 10 to the power 5 joules divided by 504.4 meters. Okay. Okay, so this works out to 374.7 newtons. So the friction force, the average friction force is 375 newtons. Okay. Okay, that finishes that problem.